Connecticut Electrical Code, or SEC, generally mandates that all service disconnects for a building be grouped in a single readily accessible location. This is detailed in CEC section 230.70. A1, which states all service disconnecting means shall be grouped together at one readily accessible location. However, there are exceptions to this grouping requirement outlined in the National Electrical Code, or NEC, which the CEC adopts in part. NEC section 230.70. A2 allows for multiple service disconnects to serve different parts of a building. This might apply to situations such as multiple tenants in a commercial building or multiple buildings on a single property. The key here is that the disconnects must be located so that they are visible from their respective service entrances. Secondly, NEC section 230.70. A3 provides another exception. It allows for multiple service disconnects to be located in different parts of a building if the disconnects are interlocking and visible from each other. An important point to consider is whether any local laws in Stamford, Connecticut, specifically address the grouping of service disconnects. Based on current information, there do not appear to be any specific local laws that override the CEC requirements. Therefore, the Connecticut Electrical Code requirements likely apply. It's important to remember that interpretations and applications of these codes can vary. Without detailed information about the specific installation, it's difficult to definitively say whether the disconnects in question meet the exceptions to the CEC grouping requirement. The electrical inspector might have approved the locations based on one of these exceptions. To gain clarity, it's advisable to reach out directly to the electrical inspector or the local building department. They can provide specific guidance on the code requirements and the reasoning behind the approval of the locations in question. Understanding the nuances of these codes is essential for ensuring electrical safety and compliance in any building project. When dealing with service disconnects and electrical codes, it's always best to seek expert advice and clarification from the relevant authorities to ensure adherence to all applicable regulations. Now let's delve into the details of service disconnects and the electrical codes. Service disconnects are a critical component of any electrical system. Their primary function is to provide a means of isolating the entire electrical system of a building or structure from the utility's power supply. This isolation is essential for safety during maintenance, repairs, or in emergency situations. The Connecticut Electrical Code, like most electrical codes in the United States, is based on the National Electrical Code, which is published by the National Fire Protection Association. The NEC is updated every 3 years and serves as the benchmark for safe electrical installations. The CEC adopts the NEC with some state-specific amendments. The requirement for grouping service disconnects is intended to ensure that all disconnecting means are readily accessible to qualified personnel in case of an emergency or for routine maintenance. This grouping simplifies the process of de-energizing the entire electrical system, which is crucial for safety. However, as previously mentioned, there are exceptions to this rule. One exception, as outlined in NEC section 230.70. 8.2 addresses situations where a building has multiple tenants or where there are multiple buildings on a property served by a single service. In these cases, it may not be practical or feasible to group all service disconnects in one location. Instead, each tenant or building may have its own service disconnect located near its respective service entrance. The key requirement here is visibility. The disconnect must be visible from the service entrance it serves. This ensures that anyone working on the electrical system can easily identify and access the appropriate disconnect. Another exception found in NEC section 230.70. A3 allows for multiple service disconnects in different parts of a building if they are interlocking and visible from each other. Interlocking means that the disconnects are mechanically or electrically linked together so that when one disconnect is opened, all the others are also opened. This ensures that the entire electrical system is de-energized, even if the disconnects are located in different areas of the building. The visibility requirement, again, ensures that anyone working on the system can readily identify and access all the disconnects. In the specific case of the contractor in Stamford, Connecticut, several factors could influence whether the installation complies with the CEC. Firstly, it's essential to determine whether the building has multiple tenants or qualifies as multiple buildings on a single property. If so, the exception in NEC section 230.70 A2 might apply, allowing for separate disconnects near each service entrance. Secondly, if the building does not meet the criteria for the first exception, it's important to ascertain whether the disconnects are interlocking and visible from each other, as required by NEC section 230.70 A2E. If both of these conditions are met, the installation might still be compliant, even though the disconnects are not grouped in a single location. However, if neither of these exceptions applies, the installation would likely be in violation of the CEC grouping requirement. In that case, it would be necessary to relocate or reconfigure the disconnects to comply with the code. It's also worth noting that electrical inspectors have the authority to interpret and enforce the electrical code. Their interpretations can sometimes vary based on local conditions and specific circumstances. Therefore, it's always best to consult with the local electrical inspector to obtain their specific guidance and approval before proceeding with any electrical installation. In the absence of any specific local laws in Stamford, Connecticut, regarding the grouping of service disconnects, the CEC requirements would generally apply. However, it's always possible that there are local amendments or interpretations of the code that could affect the installation. Therefore, it's crucial to consult with the local building department and the electrical inspector to ensure compliance with all applicable regulations. In summary, a Connecticut Electrical Code generally requires that all service disconnects for a building be grouped in a single location. However, there are exceptions to this rule for buildings with multiple tenants or multiple buildings on a property, as well as for disconnects that are interlocking and visible from each other. In the specific case of the contractor in Stamford, Connecticut, it's essential to determine whether any of these exceptions apply and to consult with the local electrical inspector to ensure compliance with all applicable regulations. Now let's address grounding multiple service disconnects. Grounding is a critical aspect of electrical safety, and it's essential to ensure that all electrical systems are properly grounded to protect against electrical shock and fire hazards. When dealing with multiple service disconnects, the grounding requirements can be more complex. The NEC and, by extension, the CEC provides specific guidelines for grounding electrical systems with multiple service disconnects. Generally, the grounding system must be designed to ensure that all metallic parts of the electrical system are bonded together and connected to earth. This bonding and grounding creates a low impedance path for fault current to flow back to the source, which helps to trip the circuit breaker or fuse and energize the circuit in the event of a ground fault. When multiple service disconnects are used, it's important to ensure that the grounding system is properly coordinated to provide effective ground fault protection. This typically involves connecting the grounding electrodes for each service disconnect together to form a common grounding system. The size and type of grounding electrodes and grounding conductors must comply with the requirements of the NEC and the CEC. In some cases, it may be necessary to install additional grounding electrodes or to increase the size of the grounding conductors to ensure adequate ground fault protection. It's also important to ensure that all metallic conduits, enclosures, and equipment are properly bonded to the grounding system. This bonding helps to prevent voltage differences between different parts of the electrical system, which can create a shock hazard. The NEC provides detailed requirements for bonding metallic parts of electrical systems, including the use of bonding jumpers and bonding bushings. When dealing with multiple service disconnects in different parts of a building, it's essential to carefully coordinate the grounding system to ensure that all parts of the electrical system are effectively grounded. This may require the installation of additional grounding electrodes, the use of larger grounding conductors, and the proper bonding of all metallic parts of the system. It's also important to consult with a qualified electrical engineer or electrician to ensure that the grounding system is designed and installed in accordance with all applicable codes and standards. In addition to the general grounding requirements, there may be specific requirements for grounding multiple service disconnects in certain types of buildings or installations. For example, In healthcare facilities, there are often more stringent grounding requirements to protect sensitive electronic equipment from electrical noise and interference. Similarly, in industrial facilities, there may be specific grounding requirements to protect against the hazards of static electricity and electrical transients. It's important to be aware of these specific requirements and to ensure that the grounding system is designed and installed accordingly. When dealing with multiple service disconnects, it's also important to consider the impact and the overall coordination of the electrical system. The coordination of the electrical system refers to the selection and arrangement of circuit breakers and fuses to ensure that a fault on one part of the system will be isolated without disrupting the rest of the system. When multiple service disconnects are used, it's important to ensure that the overcurrent protective devices are properly coordinated to provide selective tripping. This means that the circuit breaker or fuse closest to the fault should trip first, while the other circuit breakers or fuses remain closed. Selective tripping helps to minimize the impact of a fault on the rest of the electrical system and to prevent unnecessary outages. To achieve selective tripping, it's often necessary to use different types of circuit breakers or fuses with different time current characteristics. It's also important to carefully coordinate the settings of the circuit breakers and fuses to ensure that they will trip in the correct sequence. The coordination of overcurrent protective devices can be a complex task, and it's often necessary to use specialized software or tools to analyze the electrical system and determine the optimal settings for the circuit breakers and fuses. In summary, grounding multiple service disconnects requires careful attention to detail and a thorough understanding of the NEC and the CEC requirements. It's essential to ensure that the grounding system is properly designed and installed to provide effective ground fault protection and to protect against electrical shock and fire hazards. It's also important to consider the impact on the overall coordination of the electrical system and to ensure that the overcurrent protective devices are properly coordinated to provide selective tripping. When dealing with complex electrical systems with multiple service disconnects, it's always best to consult with a qualified electrical engineer or electrician to ensure that the system is designed and installed in accordance with all applicable codes and standards. Now let's talk about visibility requirements for service disconnects. The requirement for service disconnects to be visible from their respective service entrances is an important safety feature. It ensures that anyone working on the electrical system can easily identify and access the appropriate disconnect to de-energize the system. The visibility requirement is intended to prevent confusion and to ensure that the correct disconnect is always used. In some cases, it may not be possible to locate the service disconnect directly adjacent to the service entrance due to physical constraints or other factors. In these situations, it's important to ensure that the disconnect is still readily visible from the service entrance. This may involve installing the disconnect on a nearby wall or structure or using signage to clearly indicate the location of the disconnect. The NEC and the CEC do not provide specific guidance on how to achieve visibility, but they do require that the disconnect be readily accessible and easily identifiable. This means that the disconnect should be located in a place where it can be easily reached and operated, and that it should be clearly labeled to indicate its purpose. In some cases, it may be necessary to install additional lighting or other measures to improve visibility. For example, if the service disconnect is located in a dark or poorly lit area, it may be necessary to install a light fixture to illuminate the disconnect. Similarly, if the disconnect is located behind a door or other obstruction, it may be necessary to install a sign to warn people of the obstruction. The visibility requirement is particularly important in buildings with multiple tenants or multiple buildings on a property. In these situations, it's essential to ensure that each tenant or building has its own service disconnect that is clearly labeled and easily accessible. This helps to prevent confusion and to ensure that the correct disconnect is always used. In addition to the visibility requirement, the NEC and the CEC also require that service disconnects be readily accessible. This means that the disconnect must be located in a place where it can be easily reached and operated without having to climb over obstacles or move furniture. The accessibility requirement is intended to ensure that anyone can quickly and easily de-energize the electrical system in case of an emergency. In some cases, it may be necessary to install a platform or other means of access to reach the service disconnect. Similarly, if the disconnect is located behind a locked door or gate, it may be necessary to provide a key or other means of access to authorized personnel. The visibility and accessibility requirements for service disconnects are essential for ensuring electrical safety and for preventing accidents. By ensuring that disconnects are readily visible and easily accessible, it's possible to minimize the risk of electrical shock and fire hazards. In summary, the visibility requirement for service disconnects is an important safety feature that ensures that anyone working on the electrical system can easily identify and access the appropriate disconnect to energize the system. The NEC and the CEC require that service disconnects be readily visible and easily accessible, and that they be clearly labeled to indicate their purpose. In some cases, it may be necessary to install additional lighting or other measures to improve visibility and accessibility. These requirements are essential for ensuring electrical safety and for preventing accidents. Finally, let's consider the role of the electrical inspector. The electrical inspector plays a crucial role in ensuring that electrical installations comply with the NEC and the CEC. The inspector is responsible for reviewing electrical plans, inspecting electrical installations, and issuing permits for electrical work. The inspector's primary goal is to ensure that electrical installations are safe and that they comply with all applicable codes and standards. The inspector has the authority to approve or reject electrical installations based on their compliance with the code. If an installation does not comply with the code, the inspector can require that it be corrected before issuing a permit. The inspector also has the authority to issue fines or other penalties for violations of the code. The electrical inspector is an important resource for contractors and homeowners who are planning electrical work. The inspector can provide guidance on the code requirements and can help to ensure that the installation is done correctly. It's always a good idea to consult with the electrical inspector before starting any electrical work to avoid potential problems later on. In some cases, the electrical inspector may require that certain electrical work be inspected at multiple stages. For example, the inspector may require that the grounding system be inspected before it is covered up, or that the wiring be inspected before the walls are closed in. These inspections help to ensure that the installation is done correctly and that any problems are identified and corrected early on. The electrical inspector is also responsible for investigating electrical accidents and for determining the cause of the accident. If an electrical accident occurs, the inspector will typically conduct an investigation to determine whether the accident was caused by a violation of the code or by some other factor. The inspector may also make recommendations for preventing similar accidents in the future. In addition to their role in enforcing the electrical code, electrical inspectors also play a role in educating the public about electrical safety. Inspectors often conduct educational programs and workshops to teach people about the hazards of electricity and how to prevent electrical accidents. They may also provide information on how to properly maintain electrical systems and how to identify potential electrical hazards. The electrical inspector is a valuable resource for the community and plays a vital role in ensuring electrical safety. By enforcing the electrical code, investigating electrical accidents, and educating the public about electrical safety, the inspector helps to protect people from the hazards of electricity. In summary, the electrical inspector plays a crucial role in ensuring that electrical installations comply with the NEC and the CEC. The inspector is responsible for reviewing electrical plans, inspecting electrical installations, and issuing permits for electrical work. The inspector's primary goal is to ensure that electrical installations are safe and that they comply with all applicable codes and standards. The inspector is also an important resource for contractors and homeowners who are planning electrical work. By consulting with the electrical inspector before starting any electrical work, it's possible to avoid potential problems later on and to ensure that the installation is done correctly.